Good morning students, welcome to the session on data structures. In our previous lecture we have started new data structure called stack. Okay, in this we have seen how we will be placing the elements. We have taken few of the examples like this, arranging the trays and arranging the shades and arranging the points, arranging the books, all will be in your data structure called stack. Okay, we will be arranging them one by one, and when we want to take out them, we will be picking up the last element that we have inserted, that will be taken away when we want to take out the elements. That is what we are following a pattern called LIFO, last in first out. Whatever the element that we are putting at the last one, that will be taken first. See here, this book is kept first, and this one is second, this one is third, fourth, fifth, sixth, seventh, eighth. At the 8th position, I have kept my book. But when I want to take out the book, I will be picking the first book from here. That is, whatever the last book that I have placed, I will be picking that out first. Okay. This we have seen, and we have understood what is stack. Okay. We have seen so many examples also. Okay. Now let us try to understand the ADT operations that we could perform on your stack. Okay. See, few of the operations that I have written over here. Every time do remember, stack is following LIFO pattern, okay, or as last in first out pattern, last in first out pattern, last in first out pattern. Okay, why I am stressing those words means you need to remember them, then only you can understand these particular concepts. Okay, why? Because we will be having some restrictions towards our data structure. In that particular order only, you need to insert your elements and you need to take out the elements from that particular data structure. And here we are speaking about the stack by using arrays. By using arrays, we are implementing what? Stack. See here, stack operation. The bottom of the stack is sealed end. See here, you can observe this. We are having a bucket where we are ending. We have one sealed end for the bucket, so that we can put some water, we can put some books, we can pour something into your bucket. Like that, we will be having a stack. A sealed end will be there for your stack. Okay, and stack may have capacity which is limitation on the number of elements in the stack, the operation on the stacks are. Okay, now let us understand this. We have already said that stack is implemented by what? Arrays. Arrays contains what? Fixed size. Array will be declared with the size, I can say suppose int a of 10. Then only 10 elements that we could store in your array. That is the reason that they are saying stack may have a capacity which is a limitation on the number of elements in the stack. If we are giving 100, you can store only 100. If you are giving 1000, only 1000 numbers can be stored. Like that, we will be having some limitation towards the stack storage. Okay, and the operation that we could perform on your stack is first one push, and the second one is pop operation, and then next one is empty, and the next one is null. Oh, sorry, is full. Okay, see here. The first operation is push. Push is nothing but the insertion of elements into your stack. Places an object on the top of your stack, I can say, or simply I can say insertion of element. Insertion of element. Insertion of element is called as push operation in your stack. Okay, and then removal of any object, removal of any element from your stack is called as pop. That is delete operation, I can say. Okay, deletion is called as pop and insertion is called as push. And is empty reports whether the stack is empty or not. Initially, when we are creating your stack will contains no elements. That is, your stack is empty. To check whether it is empty or not, we are using the function, we are using an operation called isEmpty operation. Okay, now see the next one is isFull operation. It is quite opposite to this. Okay, reports whether the stack exceeded limit or not, or else simply I can say whether we have inserted all the elements that can stored by your stack. Okay, say suppose in this case if I can store only 3 elements, I have done with this. If I am trying to insert one more element in the stack, then I can't. Why? Because my size is 3. 3 elements have been inserted into your stack. If I am trying for the 4th element that has to be inserted into your stack, that will not be done. In order to not happen that, we will check whether it is full or not. If it is full, we will throw an error message, stack overflow. If it is not, then we will try to insert element. Okay, so these are the simplest operations that we could perform onto your stacks. Okay, in today's session you need to remember only 2 things, that stack is a data structure which is following what? LIFO pattern, that is last in first out. And do remember the examples so that you can easily remember the concept. Okay, see here, insertion and deletion. Insertion, sorry, you can see now. Okay. See here, insertion and deletion of the elements in your stack will be done from only one end. From this end only we will be inserting the element. From this end only we will be taking out our elements. Do remember that we will be having a sealed end onto our stack, so that when we are inserting the element, we will be inserting from this end only. When we are taking out the elements, we will be taking out the elements from this end only. Okay, stack push, S is your stack, push A onto your stack. So I have inserted A, push B. Oh, sorry, leave about this, we will discuss them later, but try to understand the operations. That's it. Push, pop, isEmpty, isFull. See here, they have inserted A like this, push operation. By using push operation, they are saying that they have inserted A. After insertion of these 3 elements, if the stack's size is 3, if they are trying to insert D, then we will be throwing an error message called stack overflow. Okay, see here, pop S. We will be not specifying any element. Why? Because from only one end we will be deleting the elements. No need to specify the data also. Why? Because at the top end, whatever the element will be there now, that will be taken away from your stack. That is the reason we will simply say that pop S. Okay. See here, if it is empty, if the stack is empty, then we will be throwing one more message that stack is underflow, or else stack is empty. Like this, we will be having simple operations onto our stacks. That's it for now. If you are having any doubts, just let me know by your comments so that I can clarify, and we will go for the next topic. That's it. Thank you.